Okay, I got you. All right, PowerPoint. Because this keeps coming up. I'm not sure why this is coming up. Let's check it again. Okay, let's minimize this. And let's open this guy. So it's loading up now.
Okay.
And can you see the title page?
Yeah, we can see the whole thing. Yep.
Okay, so if I zoom into it, let's see what that looks like.
Or if you just go to presentation mode, yeah, there you go.
Okay. Okay, perfect.
Okay.
Gotta get rid of this.
Let me start getting us organized then. Welcome everybody again, and we all have the presentation now, and so we are on the record, we are recording. Today is the 9th of March 2022, and this purpose of this session is dissertation oral defense for Robbie Walker. The title of the presentation is Use of Human-Computer Interaction Devices and Web 3.0 Skills Among Engineers. We have three people on the call. Dr. Branford McAllister, the chair. Dr. Robert Haussmann is the second committee member, and Robbie Walker is the student. And so what we're going to do is allow Robbie to make about a 20-minute presentation. We'll do some questions and answers and discussions primarily, and then we'll confer on the results and pass those along. And the only thing I would mention to you, Robbie, is that you know, we've all read the document a few times, so we pretty much know what's in there, but sometimes what comes across during the presentation or when we see it in a different sort of context, we may hear or see things that we might want to just get some explanation or clarification or just discuss. So we'll ask questions, but it's not an antagonistic proceeding. So we're not trying to find out what you don't know. We're just having a little discussion among colleagues. That's the way to look at it. So you don't have to hurry through it. As I told you, just hit the high points on those things that, you know, are pretty straightforward, and then focus mostly on your results and interpretation of those. And with all that said, I'm going to go ahead and be quiet. I'm going to go on mute and just let you get through it and save my questions for the end. And then, you know, if you have any issues or questions for us, we'll know it and we'll pipe in. Otherwise, we'll kind of just let you go. So any questions on that? Okay, well, it's all you, Robbie, and I'm going to go on mute now.
Thank you, Dr. McAllister. I would like to express my gratitude and my excitement for making it to this monumentous milestone. This has been quite the journey to get here. I want to thank Dr. McAllister, my chair, for your help and your patience and time in expressing my interest as well as your interest in this particular topic. Dr. Haussmann, thank you for being our support. When we run into roadblocks or whatever, you have always kind of come in and have stepped in and helped us in many ways than I can express in this moment. So without further ado, I would like to, the discussion, I would like to do a summary of the proposal as well as hone in on chapters 4 and 5. So since the 1990s, the 2010s, and the 2020s, and now today, Web 3.0 technologies will probably foster more research to be discovered. I want to kind of talk about today, though, in the future of 2020 and beyond, where the future of Web 3.0 technologies is going. The evolution of the web since Web 1.1 to Web 2, now Web 3.0, has allowed a lot of businesses, small businesses, as well as conglomerate business to operate and run at various speeds and for analyzing different data. For example, the real general problem in management was managers trying to figure out what investment to put into technology, because there's so many different gadgets, so many different tools to use, so many different web technologies to use. Where should managers kind of hone in on their investments? So I wanted to look at that problem, and this is the purpose for my study. It was a quantitative correlational study. It was used to investigate whether the use of HCI devices predicts Web 3.0 skills among engineers. The significance of this study is contributed to the management field, to HCI, Web 3.0, the IT profession, as well as social change. My research should fill the gap in describing the relationship between the use of HCI devices and Web 3.0 skills among engineers, since a lot of research has not been conducted to examine, due to the vast, rapid evolution of this type of technology. A lot of research isn't there. And consequently, managers doesn't really know, although they've made worthy decisions in the past, with the new web technologies going forward, they may need help to kind of investigate where to focus on what tools for engineers to use. So the methodology and design that I utilized was a quantitative correlational study. It was a self-designed questionnaire called the Web 3.0 Technological Skills Survey. It measured 12 independent variables, 10 independent variables for competence or reliance on and competence with HCI devices. So desktop reliance, desktop competence, your laptop category, your tablet category, smartphone, as well as wearables like smartwatches and VR headsets, as well as an aggregate indice of a value for the reliance on HCI devices and competence with HCI devices. So that compiled into 12 total independent variables. The dependent variable was Web 3.0 skills. So this methodological approach was needed to take on this type of workload, as well as to answer the research questions in this manner. The research question: what is the relationship between the use of HCI devices and Web 3.0 skills? Do the independent variables, the use of HCI devices, reliance, and competence predict the dependent variable Web 3.0 skills? And so this question explores more motivation for engineers. Motivation is like, what would engineers do? That's pretty much what I wanted to explore. How will engineers be motivated to enhance their skills when you have so many great advanced devices and tools to use? Would they be motivated to even learn about it? The hypotheses: I rejected the first null hypothesis. There is no significant relationship between any of the predictors. That's incorrect. There actually is a significant relationship between at least one of the predictors and the dependent variable. And I also reject the second null hypothesis, stating that there wasn't a significant relationship between reliance on and competence with the five HCI devices in the aggregate and their two-factor interactions, Web 3.0 skills. There actually is a significant relationship between either reliance on and competence with the 5 HCI devices, both reliance and competence in the aggregate, or their two-factor interactions and Web 3.0 skills. The sample size and participants included in this study were engineers working in small and medium enterprises in the metropolitan areas of Georgia. 214 participants returned a completed survey. The medium sample size was 178, and that was calculated utilizing G-Power software, alpha of 0.05, power of 0.95, and the effect size of 0.10. As far as the results, utilizing multiple linear regression, I utilized two stepwise approaches. The first was a statistical regression, which is an automated approach in SPSS with two methods: the backward elimination method and the forward selection method, and the sequential method, which is a manual approach. And that kind of relies more on a subject matter expert and also kind of plug and play with what the data is doing and just a general overall assessment to make the best decision for building a final predictive model. So in the statistical regression, utilizing the backward elimination method, I concluded with I produced a model initially with a few of the 4 significant independent variables, which I found that engineers rely on tablets. I found that engineers rely on desktops, and they're competent with their or they rely on laptops and tablets, and they're competent with their desktops and their wearables. And so the two-factor interactions produce that. I also utilize statistical regression with the Ford selection method, producing a model with two-factor interactions as well. When I looked at sequential regression, there were a few runs, up to at least 22 runs, and I found the final predictive regression model to include those 4 significant predictors of Web 3.0 skills, including the two-factor interactions. And it consisted of laptop reliance, tablet reliance, desktop reliance, wearable competence, and the two-factor interaction between desktop reliance and tablet reliance, the two-factor interaction between laptop reliance and laptop competence, tablet reliance and desktop competence and wearable competence, and desktop competence and laptop competence. So it's important to note here that although laptop competence and desktop reliance were found not to be significant individually, they did moderate the two-factor interactions among the other 4 significant independent variables in their two-factor interactions. In answering the research question, I propose that reliance on and competence with the 5 ATI devices could actually predict the self-reported level of Web 3.0 skills for engineers. That was to find out what was that relationship between the use of ATI devices and Web 3.0 skills. I concluded with a final predictive regression model utilizing y-hat of Web 3.0 skills and an adjusted R-squared of 0.239, which basically means approximately 24% of the variation of Web 3.0 skills was explained in the final regression model. And both the null hypotheses were rejected based on the F-test, the p-value. So yeah, here's a few more information about why I rejected the first null hypothesis. The F-test of 8.452 and its associated p-value of less than 0.001. And if we look at that first two-factor interaction, this was one of the key findings. There were 5 two-factor interactions that were significant. The first was the desktop reliance and tablet reliance. And basically this relationship shows how engineers, they rather rely more on their tablet than on desktop reliance, and the value will change. The relationship with desktop reliance and Web 3.0 skills will change depending on the value of tablet reliance. And so, as I mentioned earlier, the 4 significant predictors was TTR. DTR was not one of the 4 significant predictors. Engineers do not rely on desktops. They rather be more competent with their desktop than rely on their desktop. In the two-factor interaction between laptop reliance and laptop competence, this relationship of laptop reliance, which was a significant predictor, one of the 4, it changes depending on laptop competence. That value, it will increase. The influence on Web 3.0 skills will increase with increases in laptop reliance at the highest value of laptop competence. So it's safe to say that engineers, they will be competent with their laptop at the highest value and rely on their laptop at the same time, but overall they rather just opt for being reliant upon their laptop as opposed to just being competent with the laptop, if that makes sense. In the two-factor interaction between tablet reliance and desktop competence, the first view, so this relationship shows that the Web 3.0 skills, it changes depending on the value of desktop competence. And again, the significant factor here to hone in on is tablet reliance, because engineers, they want a tablet. So engineering management should invest in tablets for engineers and desktops for competency sake. But the influence on the slope is positive at all values of desktop competence. It's a complete system. It's good when it works in a complete system for engineers. So having a desktop to be able to be competent with, but also to be mobile with a tablet, because engineers can interact better with their tablet than they can with their desktop. You can type on tap the screen on the iPad or Android tablet, interact with widgets and devices and things of that. If we look at a second view, the desktop competence and the relationship with Web 3.0 skills will change depending on the value of the tablet. So it's positive at all values of the tablet reliance, but that influence decreases as the tablet increases in value. So again, just to reiterate, as an engineer, my reliance on the tablet, as that increases, my desktop competence will decrease because I opt more for a tablet over a desktop. If you look at a two-factor interaction between desktop competence and wearable competence, the relationship between Web 3.0 skills and wearable competence will change depending on the value of desktop competence. Both DTC and WBC were, well, actually WBC was one of the significant, one of the four significant indicators or predictors of Web 3.0 skills. So desktop competence was not. So we want to hone in on the relationship of Web 3.0 skills and with wearable competence that is positive at lower values of desktop competence, but the slope diminishes as desktop competence increases in value. So that's something to look at there. The second view, the relationship between Web 3.0 skills and desktop competence changes depending on the value of wearable. So it's positive at all values of the wearable competence, but it will decrease as wearable competence increases in value. So just to reiterate here, wearable competence was more favorable over desktop competence for engineers. They opted. So long as they know how to work a virtual headset and a smartwatch, be competent enough in that, then the value of utilizing a desktop may change. When I looked at the aggregate indices, I wanted to test these two independent variables to measure their reliance or measure the engineer's reliance and competence with HCI devices. I developed a final predictive regression equation for that utilizing y-hat, and I found that reliance on HCI devices is more prevalent than competence with HCI devices. For example, in that two-factor interaction, if we go at, well, I'll go there. In the first two-factor interaction, you'll see that the relationship of Web 3.0 skill and reliance on HCI devices, it changed depending on the value of competence with HCI devices. And reliance on HCI devices honestly was the major predictor in this particular interaction, whereas CHCID didn't even make it to the final predictive model once the analysis was completed. So therefore, I rejected the null hypothesis, the second null hypothesis, that there is no significant relationship between reliance on a competence with the 5 HCI devices. There is a significant relationship between reliance on HCI devices with Web 3.0 skills. In that second view, if you want to look at the relationship between CHCID and Web 3.0 skills, it's positive at lower values of RHCID, and that's almost even with RHCID even being like eliminated, it would increase because, again, engineers opt to rely more on their devices as opposed to be competent with their devices, because advanced devices and tools should be able to help automate processes, tasks, and make engineers' lives much easier. So the 6 key findings, I found that there is a model of aggregate indices of the reliance on competence with devices, and they're a significant predictor of Web 3.0 skills based on F of 8.452 and its associated p-value of less than 0.001 to significance and an alpha 0.05. Also, within a significant final predictive regression model, the 4 significant predictors, laptop reliance, tablet reliance, desktop competence, and wearable competence, were 4 top significant predictors of Web 3.0 skills, and that was based on the p-value and the inclusion criteria of 0.20. The effects of those 4 independent variables in the final predictive model were moderated by other variables, and those were captured in to form the two-factor interactions. For example, DTC was one of the other ones, or DTR. Actually, DTR and LTC were 2 of the major other independent variables that were moderators of the major 4 significant predictors that were included in those two-factor interactions. The next finding was that The two original independent variables, right, yeah, DTR, LTC, I'm getting ahead of myself. Yeah, DTR, LTC was the moderators. So the fifth key finding was that both of the aggregate indices of reliance and competence were predictors in a model that was significant predictor of Web 3.0 skill. And the last finding was that, or the sixth finding was that 4 of the original independent variables were not part of the significant predictor model. And those 2 were reliance and competence with smartphones, so SPR, SPC, your wearable reliance, and your tablet competence. Engineers rather rely on their tablet as opposed to be competent with their tablet, and they rather be competent with their wearable devices as opposed to rely on wearable devices. So to interpret the 4 significant predictors of laptop reliance, it's important to note that engineering management should invest in laptops because engineers favor laptops over desktops, over smartphones, and they want to be able to rely on these laptops to do their job and complete tasks, as well as become more motivated to even learn more skills of Web 3.0. The semantic web, spatial web. As far as their tablet reliance, this increases their motivation to become more interactive with different technologies. Like they're actually tapping the screen, moving things around, zooming things out with their hand, utilizing accessibility features, what have you. So it highlights that engineers' reliance on tablets coupled with their knowledge of Web 3.0, it will provide engineers a fantastic experience and probably make their job much easier for productivity. When looking at desktop competence, it's important to note that engineer management should invest in desktops while whether it's at home or whether it is in the office, because they tend to have higher Web 3.0 skills when using desktops. Desktops are easier to use. I think everybody learns how to use a computer via a desktop initially, and it just makes sense. So as far as wearable competence, it's associated with increased Web 3.0 skills because the interactive experience is you can immerse yourself into a whole new virtual world. You can look at spatial data, computer design models. You can do all kind of cool things with VR headsets and also smartwatches. You can just be on the go, get your messages and stay connected via a wearable and not have to carry around or lug around a heavy computer bag or what have you. So how do the findings relate to literature? So because Web 3.0 is still evolving, current research has not really identified significant predictors of Web 3.0 skill. However, my research did suggest, consistent with Rootman and Brewer 2016, that Web 3.0 will provide an integrated web experience for engineers across HCI devices where machines can compute, understand, and index data like humans. The IT productivity paradox from Slolo of 1957 was well documented in the literature. It also supported my research. And previous research also only addressed Web 2.0, which is more social media, and Web 1.0, which is more read and only document specific. So Web 3.0, again, is still evolving. So I'm curious to see what type of literature would happen after this research. In answering the question, how do findings relate to the theoretical framework? Statistical results of my research confirm the theoretical foundation of the system of complex interrelated variables. There were, again, 12 variables, competence and reliance on technology among engineers, which influence engineer skills and productivity levels and productivities in small and medium enterprises. So I want to kind of further understand the basis for digital technologies and computer literacy and evolving this theoretical framework. The limitations of this study: convenience sampling does not provide a same level of random investigation, which theoretically might introduce bias and impact generalization. The study was quantitative in nature, so it didn't interview engineers and get their perspective. Also, recommendations for future research: I recommend to interview engineers, which could provide a more in-depth understanding of their motivation and expectations to perform their occupations as technology evolves, as roles and positions change. as well as look at 4.0 and maybe potentially even 4.5, Web 5.0, as that is still to be determined. So any type of emerging technologies like blockchain and cryptocurrency and NFTs and things of that are still evolving and still disrupting our economy. And so recommendations for future research, I recommend scholar practitioners look at that or look at those topics. For professional practice, I think engineer managers, they, from this research, again, if they consider the reliance upon and competence with devices, then they will make a better informed decision when it comes to investments being made, as well as they will consider the thoughts of engineers and their experience and what they opt for, what each engineer is more comfortable with. Because again, some engineers were competent with desktops, but they didn't really rely on desktops. So, and then you had some that did. But overall, we looked at those 4 significant predictors of tablet reliance, laptop reliance, and wearable competence and desktop competence. So understanding what engineers want will help managers better train and better coach and motivate the engineers to develop critical thinking skills surrounding Web 3.0 skills. To conclude, I investigated the relationship between reliance on and competence with various HCI devices. This insight gained from this research should help explain HCI devices of engineers in small and medium enterprises. My research also showed that it's possible to predict Web 3.0 skills utilizing a regression model consisting of measures of reliance on and competence with HCI devices. Adopting more than one type of device as a complete system, like a complete solution, would make sense. Have a laptop, have a tablet, as well as a desktop, and maybe a wearable, whether it's a smartwatch or a wearable VR headset, will also help the engineer complete their task better. I would like to welcome, well, first I would like to thank Dr. McAllister, Dr. Haussmann, and I would like to thank Dr. Kilmer and Dr. Sandra Kohlberg, Program Director, and you are Dr. Kilmer, for helping me out through this process, and I welcome any questions.
Okay. You can probably get rid of your charts if you want, as long as you have them there. And I'll just turn it over to Dr. Haussmann for questions, and I'll listen. And then when he's done, I'll jump in and have some of my own.
Okay. I got a few. And first of all, great presentation.
Thank you.
Actually, you went through that very quickly, and I was having a little difficulty keep memorizing the acronyms, and so these questions may or may not make sense. So if they don't, just tell me. But I thought I heard you say very early on in the presentation that you had a qualitative comparative design. You didn't say that, did you?
No, it should be quantitative correlational.
Yeah.
Yeah.
I thought, okay.
Quantitative correlational studies.
Okay, yeah, all right. Yeah. Okay. I misheard it. Great. That's easy. Can you go to the G power slide?
Sure. Sample size.
Yeah. So you had a minimum sample size of 178, and you actually had 214 participating. That is excellent. You actually didn't even need that much. Standard power that we go by is 0.8, and this is just an FYI. So you probably wouldn't have needed that many, but the more you have, the more power you have. So it's great that you did that. So I commend you on that.
Thank you.
Slide 11. I don't understand that top, that first bullet point with an alpha of 0.20.
So that was the inclusion criteria that helped develop the model based upon for each of the
Oh, so you took a first model, and anything that was had a 2.0 or higher, you moved into a second model. Is that correct?
Right. It needed to be 0.20. If it wasn't 0.20, then I made a decision to either eliminate it, not really eliminate, but just
Yeah.
remove it from the model.
From the model. Okay. Okay.
Not included in the model. Let's say that.
Oh.
Not included in the model.
Okay. That makes sense. Okay.
Yeah.
This is turning out to be pretty quick, easy questions here. Question on the desktop reliance. That one really surprised me, and I'm wondering if it surprised you, because if we're talking about engineers here, if the way I think of engineers, like mechanical or electrical or whatever, they're the ones that use those massive workstations that have, huge numbers of CPUs and cores, and I would think they would rate much higher. Do you have any thoughts as to why they didn't?
Well, I'd say I don't know if engineers are relying upon desktops. Like they'll be more competent with utilizing desktops. I'm thinking when I think of desktops, I think of like the big bulky windows, stationary with the huge tower, and then you have the computer monitor and the keyboard and all these other peripherals that go with it, which are very cumbersome now in our 21st century world. To just be able to rely upon, because you have, if I want to be remote or work in a different place, it's just ideally this doesn't make sense. When you look at the data, it was kind of surprising, but not really too much surprising. So long as engineers are competent with utilizing a desktop, that's great. That's a great investment for engineering management to make.
So I'm just thinking of I did some consulting with a really interesting company. They were engineers. I'm not quite sure what type of engineer they were. This was way back in the 2000s, and their desktops were, I mean, top of the line, like the most powerful you could get. They had, I don't know how many cores it was back then, how many CPUs. But it was mandatory. I mean, what they were doing was they had a company that predicted where to drill for oil, based on who knows what goes into that. And I have no idea, but so they were reliant on those, and they couldn't like take a desktop or tablets didn't even exist back then, but like a laptop, unless they were connecting back into that more powerful machine, because you need that CPU. And like at this time, while it's getting closer, I'd say you can probably get maybe a third the power of a mid-sized desktop in a laptop. So it's just that really just struck me, like these being engineers, like I would think the bulk of their work would be set up to do working on a desktop. And I wonder if it's the case, and you wouldn't know this, and maybe they might not know this, but they might be using a laptop that is actually connected back into and using the processing power of a desktop, depending how it's set up. And I wish I had thought of that before you went through this, because I would have liked to see that as a question, but I'm not going to make you go back and do it now. So
To answer your question, I think too, I was going to say nowadays you can build a desktop computer within hours. If you go like to Micro Center and get all the parts, and you can plug and play powerful pieces. But I think a lot of engineers rely on desktops for gaming and for maybe bigger graphic loads, like for projects
that graphics especially, yeah.
Right, RAM modifications and things of that. Then that would be a huge reliance on. But because you're looking at developing the motivation behind developing Web 3.0 skills now with the semantic web, things going into the cloud, things being like Internet of Things, being able to operate devices remotely, things like that. I don't think the reliance factor on the desktop is needed as much as it was in 2000, like you mentioned.
Right. That makes sense. Okay, that's all I have on my list. Might think of something else as we go on, but I'm satisfied.
Well, thank you for your time and thank you for your questions.
No, thank you. It was a pleasure working with you through the whole process.
Okay, I'll jump in. I think that particular discussion was really
Yes, absolutely.
was a good one and very, very important. So let's think about this. So, Robbie, what in your results,
Yes.
your findings, what was that which you discovered related to desktop reliance? What did you discover in your analysis about desktop reliance based on your analysis?
Okay, based on my analysis, desktop reliance is a moderated variable. Again, it's one of the two. The desktop reliance and the laptop competence are two moderating variables that moderated the other significant predictors of Web 3.0 skills, as far as the two-factor interactions and looking at how engineers are motivated with obtaining these Web 3.0 skills. So it's still needed, it's still necessary. Individually, it's not a significant predictor, but when you couple it with like this two-factor interaction between DTR and TTR, it is a significant predictor of Web 3.0 skills. It's still a component that is necessary, but it wasn't the major component. If that makes sense.
So Dr. Haussmann brings up some really good points, and here's one. Remind yourself and us, what specifically were you testing in this research? You were trying to determine what?
The use of HCI devices, the reliance on and the competence with those type of devices. I wanted to understand how engineers use their devices, how they rely and how they're competent on their devices in the categories of desktop, laptop, tablet, wearable, and smartphone, but also see their motivation level when it came to obtaining more Web 3.0 skills.
Okay. Were you exploring, were you trying to determine an answer to this question? The reliance of engineers on desktops and the competence of engineers on desktops? Was that your quest? Was that your purpose?
It was one of them. It was one of the 5 HCI devices.
No, it was not. What does your research question say?
Okay, yeah, my research question was basically, what is the relationship between the use of HCI devices and Web 3.0 skills?
Exactly.
Right. So,
you were trying to determine not whether they were reliant on a desktop or competent with a desktop.
I see.
Right.
You were trying to determine if their level of reliance was a predictor of their Web 3.0 skills, correct?
Correct, right. And I think the sub-question I'm referring to is like, do the independent variables, the use of HCI devices, reliance and competence on predict the Web 3.0 skills? I think that was a sub-question we came up with later. But initially, yes, you are absolutely correct.
That makes sense. That makes a lot of sense. That would explain.
To clarify, yeah.
Right. So let's take this because it's really, really important, especially because your research might influence somebody to make an investment decision. So in the first place, you did in your descriptive statistics, you did have a mean value for each of the variables. So you could compare with this group of participants, you could compare their reliance on a desktop versus their reliance on something else. And I don't have it in front of me right now, but that would be interesting. But your real purpose was to say, no matter, how reliant or competent they are,
Right.
how much did that reliance and competence predict their Web 3.0 skills? So that's one point that's very important.
Yeah, good
Yeah.
point. Thank you for
Yeah.
making that.
And another point is that how the engineers looked at, self-evaluated their own reliance or competence, and let's just say we're talking reliance on a desktop. That was a self-evaluation, and I would say that there's two things that might, I don't want to necessarily say bias, but create some bias is probably not inappropriate. First of all,
Influence.
it depends on what kind of engineer you're talking about.
Right. Absolutely.
And I just, I came off a period of time where I was working with electrical, mechanical, and aeronautical engineers.
Yeah, I remember you told me. Yeah.
We did have laptops in the office, but we also had access to high-speed computing environment. And many times the laptops were just a client that got us into the heavily, the high core, high speed computing environment. So it could be that many engineers sort of just take for granted that desktops are so prevalent, especially high-end ones doing computational fluid dynamics and finite element analysis and all these really high-powered engineering tasks, that they don't really think much about a desktop anymore. It's not exciting,
Right.
but they really use them. I can guarantee it. Right, Dr. Haussmann? I mean,
Oh,
Yes.
yeah. I
Absolutely.
definitely.
Yep.
so they might not necessarily, they might rely on their laptops for a lot of things, but they take a desktop for granted. So we have to be careful not to say, well, engineering managers, you don't need to invest in desktops. Well, if it was an aero or a mechanical or electrical office,
Right.
they'd be dead. They'd be dead.
Mandatory. Right. Right.
Yeah.
The other thing is, Robbie, if you're dealing a lot with computer engineers or software engineers or web engineers, they kind of go for sexy high-tech stuff, where they're not requiring the kind of computing power to do a computational fluid dynamics on a very sophisticated entity, a body in motion within a fluid, or to do finite element analysis. They can do a lot of what they do on the web and stuff with a laptop.
Right. Just utilize the internet. Yep.
It depends on who you talk to, right?
Right.
Yeah.
Right.
And I've surveyed a variety of engineers: occupational, systems, mechanical, chemical, aeronautical.
Oh, okay.
Yeah, I surveyed a lot. I'm gonna black my screen out just for 1 second.
Okay.
By the way, on that topic,
So yeah, I needed to.
I was just going to say, when you start talking about preference, which you said a couple of times, we're not talking about somebody's preference. We're talking about their reliance or their competence and their skills. That's not really a preference. So just be careful about saying they had a preference, because that wasn't part of your research or analysis. You were talking about their self-evaluated reliance and competence with a device, as well as
their experience, correct?
Their skills.
Yep.
Okay.
So really based on their experience, not preference.
Yeah, I think so. And you remember it's self-evaluated. So
yeah,
which, I think there's some validity there. I mean, they say, well, because if you ask me, I left my wearable on my nightstand, but but I have my iPhone.
Yeah.
And my pad. Two pads.
Complete solution. Yep.
I have them all right here. My wearables downstairs. But it depends on what they're trying to do. And
exactly.
Let me just go back to the beginning, because there's a couple things I want to just clarify.
Sure.
and jump in if there's anything, but I just.
Yeah, and while you're doing that, the supercomputer from Anna Lovelace, when she created the punch cards for the supercomputer,
Yes.
that was as
Yes.
big as the room. I mean, yeah, you had to rely on that. 'Cause at that
Right.
time, that was the only computer really.
Right.
But now, like you mentioned, yeah, we are more fast, rapid moving, we're remote, high tech. We want to be able to access what we want to access when we want to access it. So, yeah.
You know what? If I had time, I'd go to my attic and pull out my box of punch cards because Robbie, believe it or not, Robbie, I started on a Burroughs 6700.
I believe
Ah, yeah.
And the Air Force Academy purchased that probably about 1970.
Yeah, it was in the 60s.
And
Yep.
we did all of our computing using punch cards.
Yeah.
And so we could get people to help us to do them. So we could write out our code,
Right.
give it to some person behind a glass, and they would punch out our cards. Then we would run it and find out after 15 minutes that we had a bug. So we'd have to fix that card, rerun it, and wait for it. And this is the way it was done.
Yeah.
But that's not that long ago. It's only 50 years ago.
Oh,
Right.
yeah.
So,
That was
Right.
today, yeah. But we've evolved since then. So every day we're evolving in technology. It's like dog years in technology. So yeah.
Yeah, right.
Yep.
I'm going to put those cards out and send you a picture of them. I've got to get up. I have to get up in the attic anyway. Because one of the things I did is, believe it or not, way back that not exactly 50, maybe like 49 years ago or 48, I wrote a program to simulate baseball, and I have the cards still on 80 character punch cards.
Yeah.
It ran really well. And actually, one of my instructors thought it would be really a good idea to market that to baseball because they could do a lot of what ifs, just exactly what they do now, all the analytics
Right.
using simulation. So
yeah, I'm gonna say you should put it like use Scratch. It's a computer programming language. And you can use blocks, and basically algorithm is just a set of instructions. So those instructions from those 80 cards, you just write them in and sequence in that program, and we can update it.
Huh.
Yeah, it's
yeah.
Let's see. Okay, back on track, and I'll get through this. I wrote down a comment from something you said. So here's kind of a deeper thought, and you don't have to make these long answers, but you talked about this notion that you were interested in understanding how, based on the kinds of devices that are available to an engineer, you could predict their motivation to develop further skills, correct? Did I kind of get that right?
Yes, absolutely.
So tell me, just in a few words, in your mind, in your heart, just as you conceived of this, what was the mechanism that you are getting at whereby the kind of devices that an engineer might have at their disposal would be either motivating to them, or maybe not just motivate, but enable or facilitate their increase in skills? What is happening there in the mind of engineers in the workplace, whereby the kind of tool might influence their motivation? What is the mechanism going on there?
So my initial thought process was, anytime I buy a new technological product, a gadget, I'm like hooked on it. I want to learn all of the components inside of it, the new 250 features of the software. I want to be able to, plug in all my other devices and complete like a home solution or a smart home or something of that magnitude. or whether if I'm in the workplace, I want to be up and running, quick task. I want to be able to see how I can make my job more efficient, to see how I can be more productive in the time allotted, with all the other people pulling at you and things you have to do and all this stuff at work. So it started from there. And it started from when I worked at a university, and they wanted to only utilize PCs versus Mac computers. So that was a question in my mind. Okay, why does corporate only want to utilize PCs and not utilize Macs? When Macs are so interactive and fun, and you can do so many cool things and projects and all that cool stuff on. So I kind of got the ball rolling there. And then as more products are released every year, it's a new product, a new gadget, a new tablet, a new this, new that. I wanted to see how engineers are motivated with utilizing these type of devices to keep learning these skills, whether these skills are valuable enough to keep learning or not.
Okay. Does it also, though, have to do with what kinds of applications might either come with or be loaded onto those devices? So
Yeah,
it could be.
Yeah, because with programming languages, you may like to program in Java, whereas Dr. Haussmann may like to program in Python. So he may only need a Raspberry Pi, whereas if you like Java, you need a Mac. You know. So, if I like to program in C++, which is the most efficient programming languages, but it's very cumbersome and you have to know those skills. I may say I may need a Windows. I may need to scale back and not have all these, whistles and all this cool stuff. Right. Makeup, just get a Windows computer desktop that can efficiently program C++ for this project or this task. So it's all dependent upon, that's where the preference piece came in, but it's all dependent upon the type of engineer, and based on their experience.
Yeah, that's a good point. That's why I'm intrigued by the fact that wearables, iPhones, and tablets would even be a part of this discussion. For one thing, here's a problem. In many of the really high-tech places that I worked, they were at the government top secret level. You could not bring in a wearable, a tablet, or a iPhone to those spaces. It was either a laptop given to you or a desktop. So it's very interesting. Every company almost has a proprietary focus. Raytheon tends to use Python to write their simulation software for their missile systems. Yep. I don't know why they do, but they do. So the machines that they have to use have to be capable of running Python. A lot of people are still using Unix operating systems.
Yeah.
Oh, sure.
So it gets really complicated because there's different operating systems. And when we were trying to design this high-speed computing environment to do some really sophisticated simulations of modern weapon systems, we had to be very flexible to be able to handle anything that the contractors might use, whether it's different operating systems or different computer programs or languages.
Right. Yeah, absolutely.
That dictates. I think it was a good point about the sample size. I just bring it up because, I'll take part of the blame for this, but I didn't steer Robbie well. And so she computed her sample size and we got it all approved in the proposal. And then when we did the sample size properly, using a random effects model for multiple linear regression, there was a little bit less sample size required. So we kind of punted and evolved
take the extra.
We took the extra. We did a post hoc power computation.
Yeah. So it worked out. So it's all
that was partly my fault. But I think a point I want to make too, Robbie, and that is we kind of work together through these different kinds of regression model building techniques. And the reason I've evolved to that is as I've studied this problem over particularly the last 10 years, there's a great body of opinion that's very, very careful not to rely on one regression technique, especially automated ones. And so there's a tendency now out in the scholarly research and analysis to use different regression model building and kind of use them collaboratively. So I forced you to to use a couple different techniques because I thought that the information would be rich. So that's kind of why we went through that. But
Yeah, and I enjoy doing it. Like I learned so much in this process.
Yeah, it was interesting, but I learned a lot from it. And even old head guys like Dr. Kilmer, I haven't convinced him necessarily. And oh, Dr. Haussmann, I was just telling I kind of forced Robbie to use a couple different regression model building techniques because there's a prevalent trend in the literature and the research out there that says try to avoid any of this a single reliance on one automated mode because there's a high, so I forced her to use a couple different ones and then kind of compare, and it kind of confused people a little bit, especially Dr. Kilmer, which
I saw that.
He was on my committee. So anyway, but nevertheless, and another trend is to be very inclusive about potential independent variables. And so that's why I've gravitated to using a more liberal inclusion criteria like 0.20, because you can actually build a stronger model. And I realize, and so does the research, that you could be getting some garbage predictors in your model.
Yeah.
But the alternative is that you don't put in what's actually a significant predictor, and you get a non-selector bias. Exactly. So we're trading off noise for minimal bias, and it's kind of just why we put 0.20.
Makes
and
sense.
I had a pretty good tussle with Dr. Kilmer about it, and I'm not sure I convinced him, but we'll probably have some more. Let's see. So I don't want to belabor this discussion of two-factor interactions. It's a challenging mental concept for many people. Yes. But we could spend like 20 days talking about factor interactions. Just remember this one thing, Robbie. The two-factor interaction does not relate to how one independent variable varies with another independent variable. That's not what it means. It means if you have the relationship between an independent variable and a dependent variable that is, let's say, a positive linear relationship. If there's another variable that we call a moderator that changes that relationship so that it's steeper or not as steep or negative, that's a two-factor interaction. It just means that one variable is acting to moderate the relationship of another independent variable and dependent variable. And so every time you have to explain a two-factor interaction, you're just saying that it's not that a person has a preference for one or the other, or that one independent variable is more significant than another one. It means that a variable could just vary the relationship or the influence.
Right.
Does that make sense?
The influence of the slope, right. It either will decrease, diminish, or increase based off of the other value. Yes, it makes a lot of sense. Yep. And I hope I explained it in that way. But yeah.
Yeah, you did.
And Robbie, I wanted to ask you this kind of one other question, and that is, if you were looking at your final predictive regressive model, and I asked you, well, of the variables that made it into that model, and therefore the ones that we would consider significant predictors of the dependent variable, and I asked you, well, which one was the most significant? Or a better question would be, for which of those variables was the dependent variable more sensitive to? Do you know what statistic you would go into that SPSS produced for you to answer that question?
I do, But here's the thing. Okay. Tablet reliance was very significant, but as well as desktop competence, which was not in the actual final predictive model, but it was a very significant individually predictor overall in what you're saying. But yeah, it was very, very prominent within the study.
And here's why that's important, what you just said. I have a paper that I'll be glad to share with you guys, but the real world is really complicated. And what we find out is that real world phenomena are not easily explained in simple terms. So we might think that something is a significant predictor, but in actuality, it's actually part of a much more complicated interaction among many factors, which means that it by itself is really not directly influencing. So, the fact that the sun comes up every day is not really influencing the fact that the paper shows up. It's a much more complicated relationship. You could probably get a significant correlation between the sun and your newspaper, but the fact of the matter is the sun's not really causing the paper to be there. And so the same thing with many complicated real world phenomenon. There are interactions which eventually, if you did it like you did it very thoroughly, you find out, DTR was really not by itself a significant influence. It just happens to moderate so many other ones that it finds its way into the model.
Right.
Okay. Other than that, I don't think I had anything else, but I made a lot of notes. So I think that you actually explained a lot of things that I had questions about. I guess the last question I would ask you then, thinking about the totality of your analysis and the potential impact that it might have on engineering managers, because after all, it's a management PhD. What is the one thing that what's the message that you learn that should be conveyed to engineering managers who have some decisions to make? I mean, what is it that you would advise them to do? What is that?
First, I would say it's a paradox. So don't get caught up in the paradox, the productivity paradox. That's been around since at least the 60s. And outside of that, I still believe that engineering management has made worthy decisions up to this point when it comes to investments being made in technologies and engineer skills. And I do believe engineering management has done the best with the information that they had at the time. Now, knowing more details of these complex systems and how they interact and how engineers will be more motivated to use them to obtain these skills, I think they can make better decisions in addition to decisions that were already previously made in the past. So they can kind of bridge those two together and kind of remedy the paradox and almost get rid of it. But that would be my huge takeaway, if we could get rid of the IT productivity paradox.
Yeah. That's very well said. And, I'm glad you kind of hit two things I was going to ask you. One was the paradox and one was engineering managers. And I think what the whole point is that you just can't throw a bunch of money and buy a bunch of stuff without thinking very carefully through what will likely be the outcome of investment in that one thing.
Yeah.
So I think that's what you're saying. And if that's the takeaway, I'm pretty satisfied that you did really nice research and generated some insight that probably wasn't there before. And so I congratulate you on that. And with that, that's my last technical comment. Dr. Haussmann, you want to add anything?
No, just I repeat what you said. Actually, during the presentation, learned a little bit more than what was in the actual dissertation. So I appreciate that.
Well, thank you, Dr. Haussmann. I appreciate you as well. Thank you, Dr. McAllister.
Okay, so I know that you did some work, and I think you did nice work, by the way, responding to the Foreman style editor. So we have one last version to look at, and
Okay.
then we'll send that to Dr. Haussmann for review. But before I get to that, as far as the oral presentation and oral evaluation, Dr. Haussmann, do you have a recommendation for me on the outcome of the oral eval?
Sure. I have a clear pass. I have no outstanding issues to resolve.
Okay.
Thank you.
So I would say let's go with the fact that, and I will submit today an approval of the oral evaluation,
Thank you.
which is a big step. Yeah, congratulations on it.
Thank you.
And then
99% of the way there.
Yeah.
Yes.
And the other thing is that we have to do then is we do the oral, and then we have to also do a final dissertation rubric, which I will also do when I've looked at the last bit of edits that you made.
Okay.
And and I'll give you some instruction on how to do that. But other than that, really, there's no need to drag this out any longer. Congratulations, big step.
Congratulations.
And I can't.
The Haussmann. So much.
Well,
Oh, my pleasure.
I thank Dr. Haussmann for his contributions, and Robbie, I know that you stuck with this, and we stuck together for a long time, and I'm really proud of you, and I'm really happy that this turned out well. So we're pretty close now. So congratulations, and I will do my thing, and then I'll send you some notes in the personal group to make sure that you know what you're supposed to do next. But other than that, there's not much more you need to do, honestly. So
thank you. That's my sister. She's listening in. She told me congratulations. Thank you so much.
Great. Great.
that makes it all worthwhile to me.
Yeah.
Hope you have plans to celebrate today.
Have what?
Hope you have plans to celebrate today.
Oh yeah, I have a bottle of champagne I'm gonna pop. I said I couldn't pop it.
All right.
Oh, good.
It's time.
Well, I know
Now it's time.
you keep some pretty late hours sometimes, so I'm sure it'll be it.
I'm a night out, so
Okay.
the energy,
Okay.
that's just what it is. So
Yep.
Okay.
yeah.
Well, once again, thank you both for the
Thank you.
great effort, and congratulations, and
you.
we'll talk soon. All right. Take care, everybody.
Congratulations.
I'm going to turn
Bye.
off the recording, and then we'll be done. Thanks again.
Okay. Thank you.
All right.
All
Sounds
right.
good.
Take care.
See you soon. Okay. Bye.